Okay, have you ever looked at a maths question and thought, wait, is this two questions in one? Well, that is exactly what we are tackling today. We're breaking down a tricky 7-mark question that mixes two different types of sequences. It's a classic example of how GCSE exams test your core skills. So let's dive right in.
Here it is, question 20, taken straight from a higher tier paper. You can see it's a two-parter and it's testing you on both arithmetic and geometric sequences. Now I know it looks like a lot, but I promise by the end of this you are going to have a super clear step-by-step method to nail both parts and bag all 7 of those marks.
Right, before we jump into the numbers, let's do a quick recap. The big difference between these two types of sequences is how they grow. An arithmetic sequence has a common difference. That means you're adding or subtracting the exact same number every single time. A geometric sequence, on the other hand, has a common ratio, which means you're multiplying by the same number. Getting this difference is absolutely key to solving this problem.
All right, let's get into part A. The question gives us 3 terms, one after the other in an arithmetic sequence. We've got x minus 4, then x plus 2, and finally 3x plus 1. Our mission? Figure out the value of x.
Here is the secret to the first part. Because it's an arithmetic sequence, the gap between the first and second terms has to be exactly the same as the gap between the second and third terms. It's this common difference that lets us build an equation and solve it.
So let's build that equation. We take the second term, which is x plus 2, and we subtract the first term, x minus 4. Then we say that has to be equal to the third term, 3x plus 1, minus the second term, x plus 2. See? We're just putting that idea of the common difference into algebra.
Now for the satisfying part, simplifying it all down. On the left side, x minus x cancels out. And 2 minus negative 4, well, that becomes 2 plus 4, which is 6. Over on the right, 3x minus x is 2x, and 1 minus 2 is minus 1. And just like that, we're left with a much nicer equation. 6 equals 2x minus 1.
And from here, it's pretty straightforward algebra. Just add 1 to both sides, so we get 7 equals 2x. Then divide by 2, and there we have it. Our final answer for the first part, x is 3.5. That's part A done and dusted, 2 marks in the bag.
Okay, time to tackle part B. Now this one is worth a hefty 5 marks, and it's where things get a little more interesting. We're using the same 3 expressions, but now they're part of a geometric sequence, and we need to find all the possible values of y.
So with a geometric sequence, we're not thinking about the difference anymore. We're thinking about the ratio. This means if you divide the second term by the first term, you'll get the exact same answer as dividing the third term by the second. That constant value is what we call the common ratio.
Let's put that idea into practice. We're going to set up our equation as a fraction. We put the second term, y plus 2, over the first term, y minus 4, and we set that equal to the third term, 3y plus 1, over the second term, y plus 2.
To solve an equation that looks like this, the best thing to do is get rid of the fractions. And we do that by cross-multiplying. So we multiply the top of the left by the bottom of the right, and the bottom of the left by the top of the right. This is a really important move that gives us a much cleaner equation to work with.
Okay, next up, we expand those brackets. On the left, y plus 2 all squared gives us y squared plus 4y plus 4. On the right, we get 3y squared minus 11y minus 4. Now to solve this, we need to get everything onto one side to make it equal to 0. This gives us our quadratic equation, 2y squared minus 15y minus 8 equals 0.
Now factoring is usually the quickest way to solve a quadratic like this. We're looking for 2 numbers that multiply to make minus 16, that's 2 times minus 8, and add together to make minus 15. A little bit of trial and error shows us those numbers are minus 16 and plus 1. So when we factorize, we get 2 brackets, 2y plus 1 and y minus 8, all equal to 0.
And here's the crucial part. If you have 2 things that multiply together to make 0, then one of those things must be 0. It's the only way. So that means either our first bracket is 0 or our second bracket is 0. And that gives us 2 possible answers for y.
So let's look at the first possibility. If the second bracket, y minus 8, is equal to 0, well, then y has to be 8. That's our first potential answer.
And for our second possibility, if the first bracket, 2y plus 1, is equal to 0, then 2y must be minus 1. Divide by 2, and you get y equals minus 0.5. And that is our second value, which means we've just secured all 5 marks for part B.
And that's the whole question cracked.
So let's just do a quick recap of everything we did, laid out nice and clearly, just like you'd see it on a mark scheme.
This little table really sums it all up, doesn't it? For part A, the arithmetic one, our method was to set the common differences equal. That got us our answer x equals 3.5. Then for part B, the geometric one, the method was to set the common ratios equal. That led us down the road to a quadratic equation, which gave us two possible answers, y equals 8 and y equals minus 0.5.
So there we have it. We've seen just how important solving quadratic equations can be, even when you think you're just doing a question on sequences. It really makes you think, doesn't it? Where else could that essential skill pop up on your exam paper? Something to keep in mind. Thanks for joining me for this one.